Consider the prompt, a pixel art train on a bridge over Monet-style water lilies with a Van Gogh-style sky. Feeding this prompt directly to a text-to-image model gives inconsistent results. The sky, water, and bridge all miss the desired styles. We can try more samples, but each new sample has different problems. Sometimes the sky style succeeds, but the water style does not. Other samples may miss features entirely. DreamWalk allows fine-grained control of style using guidance scaling functions. First, we define an unstyled prompt that produces the desired layout of the image. Then we construct rough masks for the areas of interest, water, sky, and the bridge. Next, we define separate style prompts for each area, and finally apply separate guidance for each prompt, modulated by its mask. The guidance scales can be continuously varied to produce the final result, which achieves the intention of the original prompt. Our method is based on modifying the guidance term used to define the diffusion update step. In addition to the base, unconditional term, we include multiple guidance terms that may vary spatially over the image or temporally with the diffusion time step. Varying guidance over the diffusion time step varies the type of edit the guidance term applies. Here, guidance is applied uniformly over time, producing large, volatile changes in the output image. If instead the guidance scale is ramped up late in the diffusion process, the effect is more subtle and leaves the layout of the image in place. Because DreamWalk operates solely on guidance terms, different models can be mixed to produce a single output image. Here we interpolate between a base model and a DreamBooth fine-tuned model. A guidance term including the rare token is first ramped on, pushing the result towards the training images. The guidance for the original prompt can also be increased, adding more flowers to the vase without changing its identity. Finally, the rare token is smoothly ramped down. A baseline method for mixing styles is prompt weighting, which produces a single prompt by blending the embeddings of multiple text prompts. Interpolations using prompt weighting on the left are less continuous than our interpolations on the right. The weights needed to interpolate the prompts can be hard to predict, leading to interpolations that change at uneven speed compared to our formulation. Finally, prompt weighting can move the prompt outside the model's domain, producing images that match neither of the target styles, while our approach smoothly interpolates the target styles. We now show additional results of our method. Starting from the Hokusai style, we increase the guidance of the Van Gogh style while decreasing the guidance of the Hokusai style. We then similarly ramp the style guidance towards the Monet style, then Picasso, and finally back to Hokusai. This final example shows the same style transitions for a different prompt. Thank you for watching.